This is a newer result that I thought was fascinating. This is a protein-based polymer lattice, and this was made from a combination of a hydrogel and a protein derived from cow's blood. The researchers were, interestingly, they wanted to achieve a shape memory effect. So, given a shape, you subject it to some stress, like it gets squished, and then it bounces back to the original. That's what they were targeting. What they found was that their their shapes did that, and their shapes also got stronger, which is why you have these funny kind of muscles on the shapes here. So the muscles kind of developed, or these proteins developed after they were subjected to this force. So this is very early days for this research, but I think it's extremely exciting in terms of where this leads. And again, this comes from a geometric exploration. And maybe most science fiction of all was this very recent paper that allows for real-time monitoring of a metamaterial implant that operates passively and is able to harvest energy from the use of the implant. This is a knee implant. I thought this was fascinating. I'm ready for this. I feel like this is a very cool future if this is part of it. Last example is maybe less applicable to medicine, but comes again back to this idea of observing nature and improving on it. It's inspired by spiral geometries found in nature and looks at spiral geometries as a functional element. So these researchers created these functional double spirals for a bunch of different applications. These ones are more structural on screen. They also had some grippers and things like this. But there were two things I want to highlight about this work. The first is, again, this point that they used a concept from mathematics, like just the geometry of a spiral, and they leveraged 3D printing to make it functional. That's true of all of the papers, actually. But so the use of 3D printing to make an idea from mathematics functional and material, that's the first thing. And the second thing that I think is interesting about this paper is that in order to do this research, first, they built software. So this is kind of a key point, that to make these new kinds of things, we need new tools to do it. And so these researchers made their own software. And this is really, dovetails into what I want to say about Metafold, that Metafold does this as well.